ALL welcomes David Tucker. His course is the incredible James Webb Telescope, which will start on March 2nd. For our 25 years in ALL, David has been an instructor with us from the very beginning. We welcome him back with his expertise and his scholarly research. You will find that he brings very technical information to a level that is accessible to all of us. Welcome, David.
Thank you. So this is a class about the James Webb Space Telescope. And the picture on the screen, that's it. $10 billion worth of advanced technology. Let's take a look at it and look at some of the parts. You can see at the top there are the mirrors. There are 18 sectioned mirrors in there. They're made out of beryllium and gold. And those are the mirrors that they're actually a camera. And so they are detecting infrared light, and then that light is processed. Right below that is a heat shield, 6 layers of a heat shield. And the reason that heat shield has to be on there is because this telescope detects infrared light, which is heat, just like a McDonald's heat lamp. And so we have to block out extra heat from the apparatus and the sun and the moon and Earth. We have to block all those things out if we're just trying to pick up galaxies and stars and so on. So the heat shield is very important. The temperature out there is like a minus 370, 380 degrees Fahrenheit. And so any kinds of heat will cause a problem. Below that are some instruments. Look under those heat shield layers, and there are a couple of boxes that are instruments. There are the infrared cameras, and there's a spectrograph that detects that takes the light and sorts it out to see what different kinds of elements are in there. So that's what the device looks like. Now, the reason that JWST was built was because the world did not have an infrared telescope. And so this was an exciting time to have this built, because what happens is when the light from the early universe after the Big Bang, when stars and galaxies started to grow and give off their light, okay, that light is traveling through space and time, and it finally reaches us. But in that time, the universe has expanded, and so light that was originally visible light or ultraviolet light or X-rays, those wavelengths are stretched, and that process turns it into longer wavelength infrared. So the universe out there is really cool, and we never had a way to measure it. And so that's why the telescope was built in the first place. So one of our goals is to piece together everything that's happening in the universe since the Big Bang. See, we had no way of measuring that because we had no way of measuring infrared. And so that's been the goal, to look at early stars and galaxies and other objects, black holes, to find out what has happened over time. Another reason for doing it is any object out in the universe will give off some infrared. Like when a new star is born, it will be giving off infrared heat, and this telescope now will be able to pick that up. So the last thing I had here on my list, let's take a look at some discoveries that have already been made. And the class will emphasize mostly this part of it. I will show you pictures of uh, stars and galaxies in their process and what they're doing, and I'll explain what the images actually show. So some of the things that have already been discovered are one thing, the atmospheres around exoplanets. We're all interested in whether there's life somewhere else in the universe other than on Earth, and we now have identified some atmospheres that have, they're called the biosignature chemicals, chemicals necessary for life. Now, that doesn't mean we've identified life, but some of the chemicals are there. We've also spotted one of the earliest galaxies formed at 900 million years after the Big Bang. So that's really shortly after the Big Bang happened. We've now identified a galaxy way back there in time. We've also identified they're called cannibalistic galaxies because gravity makes one galaxy combine with another one. They start hitting each other and colliding, and then they get all mixed up, just like our Milky Way. We now know that our Milky Way has gone through 2 or 3 or 4 processes where other galaxies collided with it and changed everything, all the stars and so on. So we've identified cannibalistic galaxies, and I'll show you some pictures of that process. We have just discovered in the last 2 weeks a protostar, a brand new star that is being formed now. And gravity starts that star to get the gases and the dust collide, and the star starts to heat up. It's not glowing yet, but infrared heat is being given off, and so we are able to watch a new star born. We're watching we can see galaxies from way back in time through a process called gravitational lensing. The gravity around a star bends the light, and so it acts just like a lens, your eyeglasses lenses, and we can now see galaxies way back in time. And we've also identified the death of a star. We're able to see a star when it goes through its final death throes and turns into a white dwarf star end stage. So those are some of the things that we'll be looking at, and my real goal in the class is to help you understand in the pictures of what's going on. The news is covering every time one of these new discoveries is being made now. The news is covering the happening very closely, but all they ever do is show you a picture, and they really can't explain to you what's going on. And so that's my job. My goal is to make it easier for you to understand exactly what's going on out there. So with that, that's what it'll be. I sure hope folks can find time to attend the class because some of the pictures are just mind-boggling what we are now learning about the universe and black holes too. So thank you very much.